Look at the leaves falling. Aren't they beautiful?
Yes, indeed. Wonder why all the leaves sway when they fall to the ground, yet an apple just plummets straight down.
That is because air resistance pushes the leaves upward, but air resistance doesn't affect the heavy apple much.
You mean all the light leaves fall the same way?
That's not really true. A larger leaf should fall more slowly than a smaller leaf.
Even if they have the same weight?
Yes. Let's pick up some leaves and I'll show you.
Okay, let's start out of here.
Okay.
Why do leaves fall differently than apples do? Which will fall faster when both have the same weight, large or small leaves? How can we make leaves fall straight down without swaying? Let's find out.
Hey there, and welcome to Moon Kong's Simple Science. So, the other day, I was sitting under an apple tree, and I was watching the leaves fall around me. But they weren't falling straight down. Instead, they were kind of swaying side to side as they fell. But then, an apple fell from the tree, and it fell straight down. Why do these two objects fall so differently? Well, that's what we'll talk about in today's experiments. For my first experiment, I have an average, normal piece of paper. And we will find out how it falls by watching. So I'll hold the piece of paper at nose height and drop it. So, why did the paper fall this way? Well, you could see the paper fell sort of side to side, a lot like the leaves from the tree, right? It didn't fall straight downward. Why does this happen? Let's talk about the forces that are affecting this piece of paper. This paper, like all things on Earth, falls downward because they're being pulled by gravity. And gravity is also pulling it down according to its mass. However, there's another force that is pushing the piece of paper upward as it falls, and this is called air resistance. So, as gravity pulls something downward, air resistance slows its fall. Let's talk more about air resistance in experiment 2. So, for my second experiment, we have two pieces of paper that have the exact same mass. For one piece of paper, I will crumple it into a ball. There we go. So we have a piece of paper and a ball, and we have our original piece of paper. And I'll hold them both at nose height, and we'll see what happens. So, what did you observe? Well, the piece of paper, like in experiment 1, swayed back and forth, but the piece of paper that was crumpled up in a ball, it fell straight down, like the apple did. Why does this happen? These pieces of paper are of the exact same mass, and yet they fall differently. Well, you see, our sheet of paper has a much greater surface area. Therefore, it has to push away a lot more air in order to fall downward. Therefore, it has a much greater air resistance, right? There's a greater push upward. Our ball, on the other hand, has a much smaller surface area. Therefore, it doesn't have to push away too much air in order to fall down. So it falls straight downward because there's less air resistance on the ball. So, we know that objects that have greater surface area encounter greater air resistance. Now, is there a way to get rid of the air resistance? Well, that's what we'll think about in experiment 3. So, in experiment 3, we'll talk about how we can remove air resistance. For this experiment, I have a very massive book, and I have our original sheet of paper. I'll take our piece of paper and put it on top of the large book, hold them both at nose height, and drop it, and we'll observe what happens. So as you saw, our paper acted very differently than it did in experiment 1 and experiment 2. Instead of swaying back and forth, it fell straight to the ground. Why did this happen? Well, you see, since the book is much heavier, it fell much faster, and it pushed away the air underneath it. Therefore, it removed the air resistance for the paper, right? There was no force pushing the paper upward, so it fell straight downward. So, what have we learned today? First, that all objects are pulled downward by gravity, and they're pushed upward by air resistance. Second, that an object that has a larger surface area encounters a greater amount of air resistance. And third, that a falling object can remove the air resistance from another object that's falling above it. So the next time you're sitting under a tree and you're watching leaves fall around you, remember that those leaves are swaying because they're being pushed upward by air resistance. Good to see you. Bye-bye.